Today's topic is random access protocols. Welcome. So, in multiple access protocols, it's classified as random access, controlled access, and channelization protocols. Now, you're going to see about the random access protocols: Aloha, CSMA, CSMA CD, and CSMA CA. So, random access protocol means there is no station superior to the other. There is no controlling hub or something like that. All stations are similar and given equal priority. If a station has data to transmit, it can check the link by itself and decide if it can transmit the data or wait for some more time. So, the next protocol is the first initial protocol is Aloha. So, Aloha network. A person transmitting or who has data station can transmit the data to the base station and it can get its acknowledgement. Pure Aloha, whenever a station has a frame, it simply transmits the frame. So in this example, frame 1.1 is not collided with any other frames from any other stations. Frame 3.2 or 1.1 alone have been successfully transmitted to the receiver. All other frames, total 6 frames, are being collided. Frame 1.2 is collided with frame 2.1, 3.1, 4.1 like that. So this is the collision duration, the graded shaded portion is. So the procedure for pure Aloha is start, make the initial attempt count to be 0, send the frame, wait time for 2 into TP. TP is the propagation time, the time taken for the data to be transmitted and acknowledgement to be received. Twice the time is the wait time. If acknowledgement is received, the data is successfully received in the receiver side. If not, increment the attempt count by 1. Maximum 15 attempts are allowed. After 15 attempts also, if successfully the frame is not transmitted, abort and check for the link defects. So if the attempt count is not equal to 15, choose random number R between 0 and 2 power k minus 1. Now k is incremented by 1, so k equal to 1. So between 2 and 0 and 1. So choose a number either 0 or 1, then wait for the TB time period and again retransmit the data. So this is continued until the successful transmission of the data is done. So the vulnerable time for pure Aloha is, so B send collides with A's beginning in this place, A send collides with C's beginning in this place. So the total vulnerable time is 2 into TFR. The throughput is G into 2 power e power minus 2G. So to overcome the drawback of Aloha, where many frames are collided and lost, we go for slotted Aloha, where the station can transmit the frame only at the start time of a time slot. So the time period is divided into slots periodically like this. At every slot of the time period alone, a frame can be transmitted. So here, compared to the Aloha, 4 frames are successfully transmitted and 4 are collided with some other frames. So the throughput is G into e power minus G and the vulnerable time is TFR, whereas in Aloha it was 2 into TFR. So in slotted Aloha, where single active node can continuously transmit at full rate of channel, highly decentralized, collision and wastage of slots is there still. So we go for the next method, CSMA, carrier sense multiple access, and then with collision detection, then with collision avoidance. So CSMA, carrier sense multiple access. Carrier is the link, sends the link if it is free when there is multiple access, meaning many stations are transmitting data at the same time. Check the link if it is free alone, transmit the data. Then also, when everyone are sensing the medium, also collision occurs. So A transmits the data, B starts at time T1 itself, but A sees that B transmits the data a little later, B sees that A transmits the data later. So here C also starts to send the data at C, but it finds that the link is used by A and B a little later. That is the reason collision occurs in CSMA. So there are 3 persistent strategies in CSMA. They are 1 persistent, non-persistent and p-persistent. One persistent is the station continuously checks the link if it is free. If it is free, immediately transmit the data. Non-persistent is it does not continuously check but checks after a random time, and at the random time if it is free, it immediately transmits the data. P-persistent continuously senses and then waits for some time slot based on the probability outcome. So based on the probability outcome, it does not allow immediate transmission, and again later it checks if the link is free. If it is free alone, it transmits the data. So vulnerable time is the propagation time in CSMA. So if the channel is busy, it has to wait. If it is idle, it checks for the probability, and if the probability is there, wait again for a time slot, check if the channel is busy, then repeat. If it is idle, transmit the data. This is about the 3 persistent methods. So to overcome the drawbacks of CSMA, we go for CSMA CD, carrier sense multiple access with collision detection. So here the station instead of continuously transmitting the data, there are 3 periods: collision slot where collision may occur, idle period, nothing happens, and contention period, waiting period, transmission period, the data being transmitted. So the CSMA CD protocol flow diagram. Start the number of attempts. Apply any one of the persistent method, one persistent, non-persistent or p-persistent method. Transmission or done or collision detection, yes means transmission is done, collision is detected, no. So the data is successfully being transmitted. If not, transmit and receive is repeated. So if collision is there, a jamming signal is sent, the attempt count is incremented. If the attempt count is more than the maximum attempt count allowed, abort the process. If not, check a random number, choose a random number and wait for the TB period and repeat the process. So here again collision occurs. What happens here is the A part of A's frame is being transmitted. A starts transmitting at time T1 and C starts transmitting at time T2. C identifies A's data only at T3. Immediately it stops transmitting the data. That is the reason only part of C's frame is being transmitted. And A identifies C's data only at this T4 instant, and immediately stops transmitting the data. So it detects the collision and stops the data transfer immediately. That happens in CSMA CD. So to further improvise, we go for CSMA CA, carrier sense multiple access with collision avoidance. So check continuously. If it is found idle, wait for the IFS time. And we have a contention window based on binary exponential. After that, after duration only, the frames are sent and timeout happens. So the IFS can also be used as to define the priority of the station. So based on the priority, the wait time changes. So in CSMA CA, wait for the idle time. Count started. If it is idle, wait for IFS time again. Still idle na, choose a random number, wait for all slots and send the frame. If not, wait again and again. Acknowledgement is received, the frame is successfully transmitted. If not, increment the attempt count. Check if the attempt count is less than the maximum count value, then only repeat the process. So this happens in CSMA CA. So all these methods are the random access protocol methods. Thank you.